Hey guys, this video is about scientific notation, converting numbers into scientific notation, doing some practice with them, and then doing a short, quick converting to standard notation. Okay, so what is scientific notation? Okay, scientific notation basically is an easy way to express a very large or small number. Now, significant figures must be used. So the number you're given in scientific notation, you must count the number of significant figures, and we're going to work on that today. All the numbers will be solved with a special number of sig figs, okay? Now, the definition of scientific notation is very important. It's actually n times 10 raised to the little n. There's a few other ways to abbreviate this, but this is one of the most popular ways. So the definition is a given number is written as the product of two numbers, a coefficient n and 10 raised to a power n. Typo over there. Okay. N is a number 1 to 9.9. All right. Now, if your number is less than 1.1, it's too small. If the number is 10, 11, 12, and greater, it's too large. You must move the decimal over. Now, the little n, what is that? Well, let's talk about that. Okay, n plus, meaning positive exponent, indicates how many times the coefficient big N is multiplied by 10. N to the negative, which is a negative exponent, indicates how many times the coefficient is divided by 10. Okay, there's tricks you can do with these numbers. When you know if it's positive or negative, you can manipulate this number. Okay, converting numbers into scientific method. Let's do some. Okay, numbers greater than 1. Okay, we have a little hand pointing to the left. Okay, what this tells us is that it tells us that if you're moving the decimal to the left, okay, smiley face is the decimal. If it's moving to the left, that means our exponent gets positive. So let's take this number right here, 1,500,000. It's understood that decimal point's right here, correct? We need to have our definition satisfied to where our big N, okay, is between 1 and 9.9. So we want to move our decimal point all the way over to here. So essentially we're going to move 1, 2, 3, 4, 5, 6 places to the left. And if we move to the left, it's going to be positive. So our answer is going to be 1.5 times 10 to the sixth. Okay, now let's check the number of sig figs. In this number here, there are no decimals originally starting with, so we have only 2 sig figs. Our answer has 2, and we're good. That's all we have to do. Okay, now let's look at another number. Okay, distance from the Earth to the Sun. That's pretty far, guys. Woo, that's far. Okay, so 93 million miles. Okay, this number has 2 sig figs. Okay, 1, 2. We need to have our decimal point moved. Understood decimal point is right there, correct? We need to move it all the way over there between the 9 and the 3 to satisfy the definition. So we move 1, 2, 3, 4, 5, 6, 7. So it equals 9.3 times 10 to the 7th miles. That's far. Ooh, that's really, really far. Okay, this is for numbers greater than 1, big numbers. Now let's look at small numbers. Numbers less than 1. Now the opposite thing here is if you have a number, okay, less than 1, the decimal point will move to the right, okay, and then the exponent becomes negative. So you have to move the decimal point to the right, and the exponent power becomes negative. So let's take a look here. Okay, this number here is very small. It's 0.00025. So we have to move the decimal to where it's between 1 and 9.9, and that's going to be right here. Okay, it originally has 2 sig figs. Now remember, leftmost zeros don't count as sig figs. Oh, these zeros do not count, so don't include them. So we're going to move the decimal to the right. 1, 2, 3, 4, 5. So our answer is going to be 2.5 times 10 to the negative 5. Okay, not positive, negative. The decimal point's moving to the right, which indicates negative exponent. Let's look at another one. Thickness of a cell wall. Now, cells are very, very small. So, this number has 2 sig figs, so our answer should have 2 sig figs. Now, remember, leftmost zeros do not count. Okay, we want to move the decimal point to where it's going to be between 1 and 9.9, and that's going to be right here. Okay, as per the rule of the definition of scientific notation. So, we're going to move the decimal 1, 2, 3, 4, 5. Now, this one's 5 as well. Okay, so it's 2.0 times 10 to the negative 5. This has 2 sig figs because this has 2 sig figs. This 0 here counts because it's to the right and there's a decimal point present. All right. Now, try converting these. Hit pause on the video. Okay. Remember, numbers that are greater than 1, you move the decimal to the left. Numbers that are less than 1, move the decimal to the right. Okay, so let's check your answers here. Okay, so for the first number, we want to move the decimal to the left. 1, 2, 3, 4. Spaces to the right, and it has 1 sig fig, just a 5. Now this number here, we want to move to the left as well, so we have 1, 2, 3, 4, 5, 6 to the left, 6 there. 2 significant figures, the 7 and the 2. Now this number is a big number. We want to move the decimal point to the left. 3, 6, 9, 10, 11 spaces to the left to a power of 11. Okay, this number originally has 3 sig figs, 802. The 0 in between counts. Now the numbers on the bottom, all right, you have your 0 here. You want to move your your decimal to where it's between 1 and 9.9. You want to move it to here. So that's a total of 1, 2 spaces to the right. Okay, and it's going to be negative 2. And this number has 3 significant figures. 1, 2, 6 count. Leftmost zeros do not. So it's 1.26. The next number, we want to move the decimal point to right here between the 1 and the 9. Okay, it's 1, 2, 3 spaces to the right. Okay, so it's negative 3. And originally it has 3 sig figs, so our answer should have 3 sig figs. Leftmost zeros do not count. Okay, this number here, 0.145. It's a very small number. You still have to move it over to 1 spot. So between the 1 and the 4. Therefore, it'll be between 1 and 9.9, which is the definition of scientific notation. So therefore, you're going to have an exponent of negative 1. Originally, it has 3 sig figs. Okay, so your answer has 3 sig figs. So you're good. That's it. Now, converting to standard notation, which is not in your textbook, but let's look at this. This is going from into scientific notation to out of scientific notation. So, to convert, this is how you do it. Move decimal to the right if the exponent is positive. Move the decimal to the left if the exponent is negative. Okay, that's all you have to remember. So, numbers that are greater than 1. All right, you have 1.5 times 10 to the 5th. All right, so as this number here is large, you want to bring it down to 0. So you're going to move the decimal point to the right. 1, 2, 3, 4, 5. Okay, now originally it has 2 sig figs, so you can't write the decimal there. This has 2 sig figs now, so they match. Now if it's less than 1, Okay, look at this number. It's very, very small. Okay, you want to make this number go to 0. So you want to make it bigger, essentially. So you're going to move the decimal to the left 3 spaces. 1, 2, 3. So you're going to put 2 zeros in between there. Okay, leftmost zeros do not count, so it has 2 sig figs, and this has 2 sig figs. Okay. Now this is the complete review of converting into scientific notation and back to standard notation. You really need to know the significant figure rules to be accurate. So if you don't know them, go back and look at them. There's only the 5 rules you need to know. But other than that, that's all you need to know. Putting in and putting out. And there is another part we're going to go over multiplying and dividing scientific notations. All right, guys, that's it. Bye-bye.